Question 13a, Part 1. Find the first derivative with respect to theta of sine cube theta. Sine cube theta is equivalent to sine theta all cubed. Hence, by the chain rule, d theta of sine theta all cubed is equal to 3 sine squared theta multiplied by d theta of sine theta, so that's the derivative of the outside multiplied by the derivative of the inside. And that equals 3 sine squared theta multiplied by cos theta, which equals 3 sine squared theta cos theta. Part 2. Use the substitution x equals tan theta to evaluate the integral from x equals 0 to x equals 1 of x squared over 1 plus x squared in brackets to the power of 5 over 2 dx. The substitution is x equals tan theta. So that means anywhere we see x in the integral, we're going to replace that with tan theta. Also, dx d theta is equal to sec squared theta. Multiplying both sides by d theta to make dx the subject of the formula, we get dx is equal to sec squared theta d theta. And the right hand side will replace the dx in the integral. Hence, we can write the integral in terms of tan theta and replace the dx with sec squared theta d theta. And it will look like the integral of tan squared theta over 1 plus tan squared theta to the power of 5 over 2 multiplied by sec squared theta d theta. Note that 1 plus tan squared theta is equal to sec squared theta, and this is one of the Pythagorean identities. So this equals the integral of tan squared theta multiplied by sec squared theta over sec squared theta to the power of 5 over 2. So we replace the 1 plus tan squared theta with sec squared theta, and that's with respect to theta. And simplifying this fraction, we get the integral of tan squared theta over sec cubed theta d theta. And this equals to sine squared theta over cos squared theta, so that's equivalent to tan squared theta, divided by sec cubed theta, which is 1 over cos cubed theta d theta. And that equals the integral of sine squared theta cos theta d theta. And this resembles the answer to part 1. Now to work out the limits of integration, since we've substituted theta for x. So when x equals 0, using the substitution x equals tan theta, theta is equal to 0. And when x equals 1, solving for theta, we get theta is equal to pi over 4. And that can be found by substituting x equals 0 and then solving for theta, and x equals 1 and solving for theta. Now, to make the integrand look like the solution to part 1, we multiply the integrand by 3, but then we compensate by multiplying by 1/3 outside of the integral. So the integral becomes 1/3 multiplied by the integral of 3 sine squared theta cos theta d theta from theta equals 0 to pi over 4. And this equals 1 over 3 multiplied by sine cubed theta from theta equals 0 to pi over 4. And applying the limits of integration, we get 1/3 multiplied by the square root of 2 over 2 to the power of 3. And that equals 1/3 multiplied by 2 root 2 over 8. And that equals the square root of 2 over 12.